All right, I'm working on a 1996 Jeep Grand Cherokee Laredo with the 4.0. Issue is it has a crank no start. So I have a fuel pressure gauge hooked up to the fuel pressure rail and the Schrader valve there. So if you watch the gauge there, I'm going to turn the key on, engine off. It should have fuel pressure, but it does not. Key on, engine off. You notice I have no fuel pressure. And I'll crank it just to prove it. Nothing. My battery's starting to get a little weak, so I'll be careful there, but obviously no fuel pressure. So now if you come over to the dash here, what I did notice is I turn the key on, there's no service engine light, which is telling me that the computer's not turning on. So then what I did is I plugged my dongle in for my scan tool here. Plug that in, I hooked my scan tool up, I got key on, engine off. Should have a service engine light to tell me the computer's on, but I do not. So I tried to communicate with the engine computer. So we'll connect up here. Once this loads up, I'll show you what I did. This part usually doesn't take too long. Trying to get into the engine computer here. So I hit diagnostics here, went to control unit, powertrain, engine control module. It's trying to communicate. You can see on the dongle there, the middle light's flashing, which is trying to communicate, but we'll have a no communication issue here in a little bit. Or you can see on the scan tool, we have no communication with it. So obviously the pump's not turning on. So there's a bigger underlying issue. So I'm going to back out of the scan tool here. So I'm done with this for now. Back out of that. I'm going to leave the key on, engine off. And we're going to walk over to my computer here and show you guys the wiring diagram. So I'm going to find the fuel pump wiring diagram. So the next step, what I did is I looked for the wiring diagram. So here's the fuel pump wiring diagram. If you look here, that's the fuel level sending unit. Don't really care right now. There's the electric motor. Ground there, ground 305. Goes up. There's your fuel pump relay. So you have 12 volts coming through the control side of the relay. Comes down, and the PCM controls the control side of the relay. Down here, PCM, pin C19, which and then turn and energizes that, lets the 12 volts comes through and turn the pump on. So then what I did is I pulled the relay out and I gave it 12 volts to the pump there to make sure the pump was working, just to prove that the pump was working. So I came over to the engine bay here. I got a bunch of tools everywhere here. I popped the fuse relay cover off here. They call it the power distribution center. And if you look here, this is the fuel pump relay, which is this one right here. I pulled it out. So it's going to be pins 30 and 87 for the load side of the circuit. So I have my power probe hooked up with the battery positive and battery negative. Let me get this set up here. I have key on, engine off, remember. And I'm checking these. I have 12 volts there. Actually, I got 10.7 because the battery's weak. And I got 10.7 there, 10.5, which is good. So you have two sources there. So this should power the pump up. So if I turn it off, watch the gauge now. I'm gonna give it 12 volts. And you can see the pump go up and you can, or the fuel pressure go up and you can hear the pump. So that means the pump works. So I'm glad we didn't replace the pump because that would have never fixed it. So then I went ahead and put the relay back in. So then we know the pump works. We got fuel pressure. So then I'm like, okay, well, I have no communication. The engine light's not coming on, but the pump's working. So I said, well, let's look and see if you have a 5-volt reference from the computer. There's 2 5-volt reference circuits on these. So what I did, if you come over to the wiring diagram over here again, I looked for some 5-volt reference circuits, and there is a couple. So I found a manifold, the map sensor, because it's an air density engine, and the throttle position sensor. These 2 wires here, they're spliced off, and they are 5-volt reference, 5-volt supply from the PCM. So basically what I did is I checked on pins 1, which is the white with the black tracer, to see if it had 5 volts. So if I go back over to the engine, pick my multimeter, or I can use my power probe, I turn it on, got my black lead going to battery ground, 20-volt DC setting scale, and then my positive lead right here. This is the white wire with the black tracer I was talking about. I should have 5 volts, key on engine off. But if you notice, I have 0.67, 0.69, which I should have 5 volts. So I don't have a 5-volt reference there. I got 0.67 volts. So then what I did here, don't mind this cut wire. I'll explain that here in a little bit. What I'm going to do while you're watching that is I'm going to turn the engine or the key off. And then what I did is I said, okay, I want to see, is it probably in the harness or a bad sensor taking it down. So what I did then is I unplugged the computer, all these connectors. I brought the computer up here. I'm basically going to make a power supply. I'm going to power up the computer, power and grounds. So if you come back over to the wiring diagram here. So I pull the connector pinouts. There's 3 connectors on the PCM. So connector 140 or C140. Pin A2, there's a fused ignition, 12 volts, or battery positive there. I should have 12 volts there, and I should have 12 volts at A22, and I should have 2 grounds at 31 and 32. So then what I did is, I'm not going to show you guys this, but what I basically had is I had the computer hooked up. I checked those pins, and I had 12 volts on both powers, the constant and the ignition, and I had both grounds. So I knew the computer was actually being powered up, but I still didn't have my 5-volt reference. So if you stay there, I'm going to review what I got to do here. So 2 and 22. So then what I did is, I took my leads here. I need to get some different leads to make these work, but I basically powered this PCM up. So I'm going to give power to pins 2 and 22 on connector 140, which this is connector 140 here, pins 2. And so I'm going to use that one. I'll use this yellow one. And 22. That's my power. And then my ground, I said, well, you stay there. My ground was 31 and 32. So my ground is going to be 31, 32. 31. Use this green one. And 32. It's my power and grounds. So then what I did, had my power probe hooked up, and I used these alligator clips. I got my ground here. I don't want to reverse the polarity, that'd be real bad. So these 2 are my grounds. So I took these 2 grounds, made it work. Bear with me. There we go. There's my 2 grounds, and then my 2 powers, which is what I said, 2 and 32, hooked up to my power probe here. And then what I did is, here's my multimeter here. Battery ground, took my other test lead here. And I want to check the 5-volt reference, which if you come back over to the wiring diagram here, if you look at this pinout, A17 is a 5-volt supply. The other connector has a 5-volt supply too, but it's the same exact results basically. So let's go to A17. Remember on the harness, we got 0.6, 0.7 of a volt. We should have 5. So if I go to A17 on here, I'm just going to touch the pin. That's 21, 20, 19, 18, 17. 21, 29. 21, 20, 19, 18, 17. If you look at the multimeter, God, I keep falling off this damn thing. 21, 20, 19, 18, 17. I give it 12 volts and look at the multimeter. There's my 5 volts. So you got nothing. There's my 5-volt reference. So that tells me that the computer is good. All right, so I plugged the computer back in, but I wanted to show you guys. So this circuit here, don't mind that cut wire, I'll explain that in a second. This is the one that we checked the 5-volt reference on, right? Well, the other 5-volt reference, when we back probed it too, like we had 0.6, 0.7 volts and it should have been 5. On this one, we back probed it, we had 1.3 or whatever. So it was the same thing until we took it out and powered it up just like we did a little bit ago. I had 5-volt reference here. I didn't show you in the camera, but on this one I had 5-volt reference too when it's unplugged. So we're like, okay, there's got to be a commonality between those two 5-volt reference circuits. Okay. So then what we did, I'm not going to show you either, but I used my breakout box here, hooked up to the OBD port. And in the wiring diagram, it's pins 3 and 11. It's they call it CCD or CCD positive and CCD negative. It should be 2.5 volts square wave, but I got just the 2.5 volts bias voltage. It wasn't getting no square wave. We didn't have that on there when it was plugged in the vehicle. We unplugged the computer and did the same thing, made a power supply with the battery and did it, and we had our 2.5 volt square wave and on the scope, so that was all good. So then if we walk back over to the engine bay, what I did then is I wanted to find a commonality. So if you come back over here, actually, tough pin and look at A4, it's a sensor ground. Well, if you go through the diagrams, A4 sensor ground, which is circuit K4, it's the sensor ground for all the sensors, the crank sensor, the cam sensor, the mass airflow, the map sensor, it's all the same sensor ground. So then if you come back over here, instead of depinning it, which I can fix this wire, instead of depinning it, I basically cut this wire. This is the sensor ground wire right here, from there to there. I just cut it, right? We'll splice it back together. So now, if you watch the field pressure gauge, I'm gonna go turn the key on engine off and we'll have field pressure again. The field pressure went up. If you go on the engine, or not the engine, the cab here in the instrument panel cluster, you'll notice we have a checked engine light now. And then you'll notice when I plug the dongle back in for my scan tool, I have communication. So let me pull this back up. So I got key on engine off again. The only thing I did is, remember, I cut that wire, so I unhooked the sensor ground wire that shares all the sensors, and I believe that was pulling everything down. So I went to powertrain, engine control module, and see if it communicates, and it should. And I did forgot to tell you guys when I was first initially troubleshooting this, I cranked the engine over, right? I had no RPM signal. That's another thing I noticed. You should always have an RPM signal, and I didn't have that on the tachometer. See, look, now I got communication, so I can read codes. Probably have a lot of circuit high codes in here, which I do because, well, nothing's going to the ground because of that central wire. I can read all my live data. But as soon as I plug that wire back in, I won't have any communication. So I'll show you this live data when it pulls up, just to prove, obviously it's got communication. Once it pulls up. So you can see I do have live data. Of course, I got 5-volt circuits here and all that. So I'm going to back out of the scan tool now. And let me get out of this. Come on. So I'm going to unplug this. I'm going to leave the key on, engine off again, just to show you guys what I did. Go back to the engine bay. So now if I hook that wire back up, just use basically these jumper leads here. I have no communication. The check engine light goes off and all that stuff because it's taken at the ground. So what did I do then? I started unplugging all kinds of sensors that share that same exact sensor ground. I'm going to plug them back in for now. Actually, I'll leave that one to show you. But I unplugged throttle position, the map sensor, the vehicle speed sensor, and the transfer case, all these sensors. The last one I got to is the crankshaft position sensor, which is right here. We already pulled it out of the bell housing. But if you look at this, you look at my multimeter, right now, I have no 5.0 reference. I got 0.7 whatever, right? So that's wrong because this is resembling the wires together. But if I unplug this crank sensor, it goes to 5 volts. Fuel pump comes on, we get pressure. If I plug it back in, it takes it back down. Then everything turns back off. So I did check the wires on that harness side. I got a 5.0 reference, the sensor ground obviously, and the signal return, all that was good. The crankshaft sensor is pulling everything to ground. So what we did do is you can take that off obviously and make it work, but it won't run because without a crank sensor it won't have spark and ignition. So what this vehicle needs is a new crankshaft position sensor. So to prove that the crankshaft position sensor is bad, which, I mean, we got enough evidence there, obviously. I hooked up my oscilloscope here, just like I did with the breakout box, to get it all set up here. I'm on channel A. Once it recognizes it, I have it on a 10-volt scale, 1 second division. We'll let that play. I took my black lead from my scope with the battery ground. And then my positive lead, what the heck did I do with that thing? Right here. Okay, my positive lead, I'm on the camshaft position sensor, which works fine, but I just want to show you how the square wave looks. Look at the diagram to the signal wire, it's just a 3-wire sensor, so I go to that. And then, if you look at the scan tool now, it's actually only got it's like 1.7 volts. So then what did I do? I hooked that sensor ground. It went back up. Hooked the sensor ground back up. It goes back down. So I'm going to unplug the crankshaft position sensor just to get rid of that. Let's see where we're at here. Just watch that scan tool. So I tried to start it again, but the battery's so dead from troubleshooting it for the last few hours. But anyways, I would have had a square wave on the scan tool here for the camshaft position sensor, which I did, but the crankshaft position sensor, I did not have a good square wave. Well, I didn't have anything. It was just a bunch of distorted noise because obviously that crankshaft position sensor was shorting everything out internally. So what it needs is a new crankshaft position sensor. So we will be putting one of those in. And that is it.